Today, we're going to start with chemical reactions. Now, before we start with chemical reactions, we need to understand what is physical reactions. Now, in a physical reaction, victims do not rearrange to produce new substances. They're usually easily reversed and easy to separate. Now, one example of this is the changing of state, like this ice cream melting. This means that it's changing from a solid to a liquid. Secondly, it will be a mixture. So when we make a mixture of two or more substances, like egg and water or egg and oil or sand and water, it's also a physical change. Then the last physical change that we're going to have a look at is dissolving a solute into a solvent. So making a solution. So when we do this, a lot of times, like if we add dye to water or if we mix eggs and oil to make a mayonnaise mixture, then it's also a physical change because the atoms or the substances stay the same. They do not get rearranged. Okay, so let's talk about chemical change. Now, when a chemical reaction occurs, a new chemical substance will be formed. Now, this chemical substance will have different properties to the reactants in our reaction. These reactions are usually very difficult to reverse. Now, there's several different ways that we can identify a chemical reaction. The first way is through a color change. So, if we think about a metal displacement reaction, so this is when a metal atom moves from one molecule to another molecule, like for instance, copper. So copper is usually orange brown. Now, when it's added to a colorless solution of silver nitrate, the copper will displace the silver from the solution. So this will cause two color changes. Firstly, the solid inside the beaker will change from orange brown to silver, meaning that the copper will be replaced by silver. Then the solution will change from colorless to blue, and this is because my copper now binds with nitrate to form a copper nitrate solution. So do you see how my molecules changed and my atoms rearranged? First, I had copper metal with silver nitrate, and as my products, I had silver metal with copper nitrate. The next observation that indicates a chemical change is a change in temperature. Now, chemical reactions give a temperature change, and they can then be grouped into two different types of reactions, and we've done this in a previous section. They can either be exothermic, and that is when they give out heat or give out thermal energy, or they can be endothermic, and this is when they take in heat or thermal energy. Now, exothermic reactions increase in temperature. So these include reactions like calcium oxide with water, which then forms calcium hydroxide, or the reaction of sodium with water. Now, endothermic reactions decrease in temperature. They are less common, but examples include like photosynthesis and when solid ammonium chloride is dissolved in water. Here, thermal energy is absorbed from the surrounding, causing the temperature to decrease. Now, this reaction is commonly used in cold packs. The last indication of a chemical reaction that we're going to look at today is effervescence or fizzing. Now, chemical reactions that cause effervescence usually involve a gas being formed. This is usually with reactions of acids. They can also involve reactions of alkali metals with water, like for instance sodium and water that will then release hydrogen gas. Other reactions that can also indicate a chemical reaction that we'll just quickly go through is light being produced, sometimes a smell being produced, especially when ammonia is being formed, and also a change in pH. We need to remember that we cannot solely rely on these indicators to identify a chemical reaction. If we add food dye to water, we can also see a color change, but that doesn't mean that a chemical change did occur. Temperatures also decrease or increase when a phase change occurs, like for instance when water is melting. But it does not mean that a chemical reaction occurred. So let's quickly look and summarize the differences between physical and chemical reactions. So, first of all, physical reactions do not form any new substances. The only thing that happens is they physically change visually. In chemical reactions, new chemical substances are formed. The atoms rearrange and form bonds with other atoms to form new substances. Physical reactions are also easy to separate and easy to reverse, whereas chemical reactions are not as easy to reverse. Now, examples of physical reactions include changing of state like solid to liquid, also mixing substances and dissolving substances into a solvent. Now, chemical reactions include endothermic and exothermic reactions, redox reactions, combustion reactions, electrolysis, and also reversible reactions.